Hi. In this video, I want to show off some of the new features that have been released in 2020.4 that allow us to perform more rich variable substitution into configuration files like XML, YAML, and Java properties files. And we'll show that off by creating a deployment that deploys a Spring Boot application from Octopus into Tomcat on a Linux box. So to get started, we can see here that I'm running Ubuntu 20.04, and I have set up this particular virtual machine as a deployment target in my hosted instance of Octopus, and that's this one here. And so I've used polling tentacle here, so my development machine can reach out to the internet and establish the connection. And this allows us to work around the fact that most development machines won't have a public IP address that they can refer to for incoming connections. I've also uploaded a Java application, and that's this one here. So this is a WAR file, and this has just been uploaded directly to the built-in feed in Octopus. We'll also actually deploy a certificate to Tomcat to show how we could manage HTTPS certificates. And to do that, I have this self-signed certificate here, and that's something I've generated locally on the machine with OpenSSL. And the commands to create these certificates will be in the associated blog post. But I've created that offline and uploaded it here. So my machine has Tomcat running on localhost, and by default that will be on 8080. So this is the standard welcome message from Tomcat, and I've also installed the Tomcat Manager application, and that's this one here. So something to be aware of with especially in Ubuntu, is that Tomcat and the Manager application are two separate installs. So this package here is Tomcat itself, and this additional one here is the Manager. And so both will need to be installed in order to get this interface here. And we'll use the Manager interface, the API that exposes in one of the deployments, I should say. And so we'll see that in action shortly. The other thing we do need to do with Tomcat is create a user. In this case, I've created a user called admin and given it these two roles. So Manager GUI gives this admin user access to this web-based interface, this one here. And then the Manager script role gives this user access to the API that the Manager application exposes. And so that came from this file here, varlib tomcat9 conf and tomcat users.xml. All right, so to get started, we'll create a project. Deploy to Tomcat. And the first step that we will use to demonstrate a Java deployment is the package copy step. So there's typically two different ways to deploy a Java application. For Tomcat and Wildfly, Octopus has native steps. And for most other application servers, and actually for Tomcat and Wildfly, if you want to, there's a step that deploys a package directly to a location on disk. And most application servers have the ability to monitor a particular directory for new files and deploy them when they're detected. So we'll use this with Tomcat first, just to show how it works. So I'm going to select the random quotes application from the built-in feed. This role here is the role assigned to the tentacle that I've installed on my Linux box. Now, so the package file name here we'll just say is random quotes.war. So what will actually happen in the background is Octopus will send the package from the built-in feed to the target. It will extract it perform some variable replacements and other modifications on any files that have been defined, and then repack it up into this file here. I spelled it wrong, so random quotes. And to have this, this repacked file put in a directory that Tomcat understands, we need to specify the custom directory. And for the default installation of Tomcat, the directory that we install to is this one here. Purge will optionally delete the contents of this directory before it's before the file is copied in. We don't actually want that though. This directory is expected to host a number of different WAR files at the same time. So let's go ahead and save that, and we'll do the deployment and just prove that everything worked as we expected. So you can see the WAR file from the built-in feed was copied down to the target. It was extracted and then repackaged, given the file name that we specified, and then that file was copied over to this directory here. So if we go and have a look now in this directory, we will see the random quotes WAR file. And this directory here is Tomcat detecting the presence of this archive and extracting it and deploying it. And so if I go back to my browser, I can open this application up, and everything has deployed as we expect. So one of the new features in Octopus 2020.4 is the ability to inject values into config files like YAML and XML. So Octopus has had this functionality for quite some time, but it was limited to JSON files. And typically, certainly within the Spring ecosystem, YAML files are definitely more prevalent. And in the older style of Java apps, XML was typically the most popular config format. So JSON didn't really play a big part, and that was a big hole for people deploying Java applications. And fortunately now that's something that's been solved with the latest release of Octopus. So the way it works is we need to enable a feature on the step. So these two features here operate on or change the contents of files. The structured configuration variables is like a push model. It takes the contents of a variable in Octopus and injects it into an existing valid unprocessed config file. JSON, YAML, XML, and Java properties files are what are supported here. The substitute variables and templates is it takes a file that has placeholders in this format here, and it will search for these and match the variable name to the associated variable defined in Octopus. So the downside to using the variable substitution is that you need to have a generic and Octopus specific config file. So this format here is the format defined by Octopus. And you may find it's not actually possible to have, for example, a valid XML file that also has these templates inside. And that can lead you into a situation where config files can't be used for local development, for example, because when you're developing locally, you're obviously not running that deployment through Octopus to generate the final files. And that can be a bit of a headache if you're trying to develop locally as well as create config files that can be transformed for each environment that they're getting deployed to. And so this option here, the structured configuration variables, is a better option for that. So this means that you can have a valid and uncustomized config file, and Octopus will reach into that file and replace specific properties based on the variables that are defined in Octopus. So this means your local development can work on just a standard unmodified config file, and then once the deployment is processed through Octopus, certain properties will be changed as needed as it gets deployed to each environment. So we'll enable this feature here, and this will expose the ability to find a list of target files to process. And so there's two files that I want to show off in this particular application. The first one is the standard Spring config, YAML config file, application.yaml. And the second one is the web.xml file that has been around for years now in Java web applications. And so while Spring is actually quite, has a lot of functionality in the ability to perhaps have variables defined as environment variables on the target machine and then read in as part of these config files. The web.xml files are a good example of formats that really don't have any facility to consume external config variables. And the file itself has to be called this, and it has to be valid to do local development. So by enabling this feature and injecting values or pushing values down into a file like web.xml, we can facilitate that workflow where local development doesn't require any specially configured config files, and Octopus knows how to modify that file during deployment to make it environment specific. So I will save that, and we then need to define the variables themselves whose values will be placed into those two files. So the variable name is a special format that identifies a property in a particular file. And so in this case, this is the spring.profiles.active property of our YAML file. Actually, we can see that here. If we go to so it'll be in metainf, sorry, be in webinf. So this is the file that I want to modify, application.yaml. And this is the value that I want to change, Spring Profiles Active. And so this value here defines the active profile for the Spring application. And we've printed that value out here on the web app in this particular part of the text here. And so what we want to do is change the value that gets displayed here by changing the name of the active profile. And so what we'll do, I'll just set this to a value that will be easy to identify in the final output. So we'll set it to this big long string here. This is not something you do in production, but it makes for an easy demo. And the next one we want to do is change the display name of the application, and that's defined in the web.xml file. So the display name is the value that gets put into this column here from our the manager application. If I just refresh that, we'll see today it's called random quotes, and that value comes from so if we look in, so this is the file that we want to modify here, web.xml. And this is the property that we want to change. And so we want to change the value inside this element here, display name, to something else, so we can see this, this variable injection working. So while this format is fairly easy, it's just property colon, and this is shared with the JSON file manipulation as well. The syntax for modifying XML files is based on XPath. And so in this case, we've said grab any element with of the name display name, and this asterisk here means match any XML namespace. And so this will then match that, that XML element that we want to change. So I'll give that a new value, again, one that'll be easy to distinguish from the existing value. So if we go ahead and deploy that again, what we'll see in the logs is the two files that we expect being processed. So there's my application.yaml, that one there, and here's my web.xml. So these two files have been processed. So if we look in webinf again, and we cat the web.xml, we will see that that value there has now been changed by Octopus during deployment. And if I display the application.yaml file, we'll see that this property here was also changed. And we can see that in action. If I refresh the page here, the application name has been changed. If I reload the application, we'll see that text has been changed. So this is a good example of being able to take a package that was not specially configured for environment-specific deployments. It was really configured to allow local development to be easy and not require any particular workarounds or embedded environment-specific config files, and then relying on Octopus to make the required changes as it gets deployed out to the live systems. So that was one way of deploying an application. And so this works for a lot of other application servers as well. So if you have WebSphere, Payara, any of those other enterprise-y application servers, the deploy Java artifact step is going to give you the ability to push out customized Java applications into those application servers. But we do also have a specialized deployment for Tomcat, and this takes advantage of the API exposed by this manager application. Otherwise, it works mostly the same way. Select the package, select the target role. Here we define the address of the manager, and this is relative to the tentacle. And so the tentacle is installed side by side with Tomcat here. So as far as the tentacle is concerned, it can access Tomcat on localhost. These credentials here have to match the values from Tomcat users. So in this case, the username is admin and password is password01. Context path defines the path that we can use to access the deployed application. Deployed version we'll leave blank for now. This is used to deploy new versions side by side in a parallel format. It's useful for zero downtime deployments, but we won't be covering that in this example here. And this step also has the same structured configuration variables feature, and we'll just enable that and target our two config files. All right. So what I will do is just change the contents of these variables just to make sure that we can prove that the deployment worked successfully. Okay. So we save that, create the release, and do the deployment. Again, we'll see the file replacement, the file processing happening as it did before. And there we go, the application has been deployed. So if we refresh this page, we'll see the display name has changed and the text here has changed. So we can prove that the deployment went through successfully. So the next step will then be to add a certificate to our Tomcat instance to allow HTTP access. And we'll do that through a runbook. Typically, these kind of management operations are best done through runbooks. It gives you the ability to manage environments outside of the normal progression of, say, dev, test, and prod that you might push deployments through. And certainly for things like certificates, if you have a new certificate, you just want to be able to put it in prod without necessarily having to push it through every other environment first. So the step that we will use is another dedicated Tomcat step, and it is deploy certificate to Tomcat. So again, role is web. So we need to know the location of certain files, certain XML files that this step will modify. And the location of these files is based on these two paths, Catalina home and Catalina base. The easiest way to find out what those values are is to have a look at the service that runs Tomcat. So this file here is the systemd. Oh, that's technical. Actually wanted Tomcat. That will be under lib. The system Tomcat. Right, so systemd actually has services in two different locations. This one tends to be for third-party applications, the etc directory. The lib directory tends to be for packages installed through the standard package manager. And so this file here is the details of the Tomcat service, and we can see here that this service has defined these two values, Catalina home and Catalina base. And so these are the two values that we'll use and that we'll place into our step. So Catalina home is that one, and Catalina base is that one. So we'll need a new variable referencing that certificate, that self-signed certificate that I uploaded earlier. Set that to a certificate type and select the certificate from the library. If I refresh, I can now select that. There's a whole bunch of different implementations for HTTPS in Tomcat. Typically, from top to bottom here, you get improving performance all the way down to Apache Portable Runtime. These do sometimes require that you have third-party dependencies installed. I'm going to leave it as the default of non-blocking I/O, which I know works. But if performance is an issue here, you would definitely want to select one of these other options and make sure that you have the associated dependencies. We'll expose HTTPS on port 8443. I won't do anything about SNI at this point. SNI allows you to have multiple host names and matching different certificates. But that's not something we'll be doing in this particular demo here. You can also define some of the details of the resulting key store file that is used to save the certificate, but we'll just leave these as default. So if we go ahead and run this, okay, so our certificate was successfully deployed. You can see the config that the Octopus created in the server.xml file. So it's actually this setting here that was added. And so this is, you can see the protocol, the non-blocking I/O that we selected, and the details of the certificate, of the key store that Octopus created. to contain the certificate. So if we go back to our browser now, we should be able to open this on a secure port. And there we go. So we can see it's not secure because it's a self-signed certificate, but that is what we expected. So that certificate has been deployed properly and is working as we expect. So that's the demo that I wanted to show off today. For those people who are looking to deploy Java to application servers like Tomcat, the ability to replace values in otherwise unspecialized config files, XML, YAML, and Java properties files is a powerful new addition. It does mean that you can go from a local development and an archive created from a local development instance with no particular environmental awareness or specialized config files that target any given environment, and then have Octopus inject those variables into the config files during deployment time, creating an environment-specific configuration. And so the values that I've put in here are obviously quite trivial, but you can imagine that injecting things like database connection strings would make this feature very useful. So thanks for listening. There'll be details in the associated blog post. And if you have any comments, reach down at the bottom of the blog post and reach out. Thanks a lot.